This is Masoud, and we are in this new session. This is
Omid.
Omid.
Hello everybody, thanks for watching us.
My partner in pair programming this. So last session, as you remember, we talked a bit about a new subject. We talked about classes, and we wrote a class named product, and we used it in we replaced the two mutable lists of product names and product prices with a new list of product list. That is a list of products. And here we are using class as grouping the distributed information about a subject into a template that we can create instance of. So then we created a product here. For inside the create single product function, we created a product. Then we changed its properties, the name and price. Now is called the property, not the field. There is
the property of the product class.
Yes, there is a slight difference between field of a class and property. In Kotlin, these are fields, these are properties, not fields. I will explain the difference later, but just bear in mind that these are called properties, the properties of the product. So we had these primitive types built into language like numbers and booleans and strings, and we introduced a new type of data into the language.
That's our own type.
That's our own type, yes. This is our own type, and we can create as many as we like. We can create multiple instances of it and store it, for example, inside in a list. Instead of adding these product names and prices into two separate lists that we have commented these lines, we decided to create a single product and store its properties into a single object. So this is our class. The class always has got a constructor that will be called only and only the time that it is being instantiated, just once, and always it will be called the constructor. The constructor function, this constructor function takes nothing as argument. For the moment, it takes nothing. And when we want to instantiate and create a new instance of a class, this is the syntax that we use. We write the class name followed by parentheses. It is like calling a function, actually. And actually, we are calling a function. We are calling this constructor function. And this constructor function should not return anything. It cannot, for example, say that I'm returning an integer or something other, because it is actually returning a new product instance. Truth be told, it is actually returning a new instance of this product, that it has its own name and price in it. So the syntax of writing constructor in Kotlin is the keyword constructor, but in Java the constructor should be the same exact name of the class. In Java it is like this. You have to write exact name of the class as the constructor. But here you should use the constructor keyword. And when you instantiate, you don't have to use the new keyword.
Yes.
There's no need for that. You should only call the constructor function. For example, if your constructor has an I of type int for its instantiation, for example, the initial price, for example, then it takes the initial price and gives that value to its price, instantiates its price with the initial value. Then, because you are calling the constructor function here, this constructor function asks us an integer now. So we should pass an integer. And as you can see, it is saying that this 234 is being assigned to the initial price. So actually, as you can see, we are calling this constructor for instantiating a class. So let's just get rid of these. This constructor for now has an empty body. Okay, let's get rid of these lines also. So this function is now creating a new product, and it is assigning it. No, it has not assigned it. It has not assigned it yet. Yes? To the list.
Yes. We
This
didn't add it to
product,
list. Yes.
product list.
Mhm.
So we have product list dot add this new product. We create a product, we ask for its properties, we assign its properties, then we add this product to the list. And each and every product will have its own properties, you know. So when you create a product, it creates two new properties and fields for it that is dedicated to it. And I recall that we were trying to persist the state of the program, of the application. We were trying to store it to the persistence. And before that, we decided to talk a little about classes and grouping the information into a class.
We have talked about the file a little bit.
Yes.
We wanted to use a file, but
this session we want to use file, and we want to get to know files more, and we want to use them. So for the moment, this menu can create single product by pressing 1, and we can also print the product list. Let me write the print the product list. Print product list. And as you see, this function does not exist. I press Alt Enter and I say, please create this function for me. It creates this function for me, and I like having this and printing the customer list. I'll say that if
customer
product list
that
size is less than 1, so go ahead and first of all you should return at the end. Before that, print that
there is no product.
There is no product. And we have a for each loop for P inside product list, and we say that okay, we print ln that product, for example, P dot name and P dot price. It has a single line of code, so I get rid of the extra braces, and at the end I want to print these dashes as a separator. So now if you run application, let's get rid of these. If we run the application, we can create products and we can print the product list. But every time we run the application, this is the first time we are running the application, and if you say, for example, print the product list, there won't be anything. There is no product. We want the application to remember the created products for the next run, for the next execution. Each time we modify, we create a product, we want this application to remember things. We want to store them to the persistence. So if we, for example, create a product Apple 1000, and we say print the product, it will print them. Product Apple 1000, end of the list. And if we, for example, exit the application and run the application again, it won't remember anything about last execution.
Yes, exactly.
So let's continue from storing to persistence. So as I remember, I described and explained a bit about the only way of persisting things into in the program.
That's fine.
That is, yes, the only thing that we can use for persisting is file. Whether you are using, for example, SQL database, or even you are connecting to some kind of back-end service. If you are connecting to some kind of back-end service, it is storing the thing that you've given into a file.
Yes.
So if you are not storing in a file in your environment, you are actually passing it to someone else to store it. in its environment. So actually, it is always the file. We are involved with files. The file is involved. So there must be a way in Kotlin API to connect, create, modify, delete, read, and write off of a file. So we should be able to create file, delete file, read off of a file, or write to a file. Yes, the API of Kotlin should allow us for doing that. And in every programming language, no matter what you're using, Python, PHP, Java, C#, whatever, there is always a mean for manipulating files. There is always some API inside for working with files, because you cannot do it on your own. You cannot, for example, write API inside, because after all, our application has to use for example, I'm using the application inside Ubuntu. It is a Linux-based operating system. Our application actually has to connect to the operating system and, for example, command the operating system to create a file in some directory or folder, or, for example, to read from it. It has to come into the operating system, and this is something that is done for us always by the programming languages, and we have to only check for the API. So first of all, we should be able to, for example, this is my file explorer. This is my home directory. Say we want to access what?
Music.
This pictures, yes. This pictures folder. I've got this picture folder, and say there is let's have it actually a text file for the moment. Text file. Let me just create a text file here. Test.txt. And for example, write hello file inside it. I save this file, and as you can see, there is this test.txt file inside my home, and the absolute path in every operating system, there is a kind of addressing a file. So in Ubuntu, in Windows, all the paths to files begin with, for example, a name of a drive, colon, 2 backslashes, and then the folder, and then backslash, then another directory folder, then backslash, then the file itself. This we call this an absolute path. Absolute path begins from the name of a drive inside Windows up to the exact file or folder or directory that we are pointing to. In Ubuntu or Linux-based systems, the absolute path starts from a slash. This is the root. This is the root. There is no drive. There is no drive CD. And if you plug anything, any kind of hard drive or USB card or flash or anything, flash memory, it will be mounted as a subdirectory. For example, as you can see, this bootcamp is actually a drive. It's actually a hard plug into my system, but it is in the media directory inside this mass.ud, and it is named as, it has been mounted as bootcamp 1, like a folder. It is like a folder. So if I go, for example, one directory back, you'll see that it is actually a directory. So you should see this difference based on your operating system. If it is Mac, it is Linux based, and it's like Ubuntu that I have here. But if it is Windows, you should be aware that the absolute path is to start from a drive name. So to access this test.txt here,
we should know the absolute path.
We should know the absolute path, and the absolute path is /home/mass.ud folder, and then this file name. So we have a special class inside the development kit, Java development kit, and in Kotlin we are actually using the Java development kit, the JDK. We have a special class named file that we can instantiate, and as you remember, instantiating a class is by calling its constructor. And it gets and a string, a path. The path.
It is not necessary to make a variable of that
Yes, we will make
later.
Yes. So it begins with a slash, then home, and then Masudi, and then the file name text.test.txt, I think. Test.txt, yes. So as Omid said, I assign it to a file, my file. So I've instantiated an object from file which is connected to this path. There may be this path, this may exist or not, and now in our case, it is actually pointing to an existing file. For example, you may address something that does not exist yet. For example, test2.txt. So let's just experiment a bit with. Let's comment these out and experiment a little bit with file. For example, I want to print ln if my file. There is a special function in it that we can ask exists, that returns a boolean,
True or false.
And if I run the application, you will see that it says false. This path does not point to some existing file. But if I say test.txt and run it, you'll see that it states true and this file exists. So if I have a non-existing file, I can actually command this to create. I say create a new file, create this path. I know that this path points to some non-existing file, but I want you to go ahead to this directory and create this file there. So if I run, this time this will create.
And then says yes.
And it will say that true, it exists. And if we go there, we'll see that it has created this test2.txt file for us. It has been created for us by these lines. So we can command to create new files. We can say, for example, delete the file. This time the file does exist, and we say delete, and then it will say false, and the file has been deleted. As you can see, there is no test2.txt. So we can there are a lot of functions in here that we can use to manipulate the file, and I don't want you to
go through.
Yes, go through all that. For the moment, I want to just show you how to connect.
Write and read
from a file. Yes, actually, reading and writing from a file. And I don't want you to. So let me just. There are some helper functions in Kotlin. For example, if you say read text, it will read the whole content of the file and it will return it as a text. But it is actually using file input stream underline. And you've seen input streams in Java. And it is using the Java development kit. Okay, so but if we want to, go with the easy way and for the moment, and not get too overwhelmed with the stream thing, I suggest that we, for the moment, just call this function
the simplest way of that.
The simplest way, and ask the Kotlin development kit to ask the Java development kit to use input a stream of file, and then read all the content of the file and store it into a string, and then it will return to us the file. So if I print the file here and press Shift F10, it says that yes, the test2 does not exist. No such file or directory as
But it has
test2.
created it.
No. We are
Deleted it.
Yeah, we've deleted that. As you can see, it is printing hello file. So inside the test.txt, we have this hello file content, and it is reading for us. And also, we can, for example, write some content in it. We can say write text.
We can write whatever we like.
Yes, whatever we like. For example,
we are writing to the text.
Hello from application, for example. Then if we read the text again, read the content of file, as text again, you will see that it has actually overwritten. It has overwritten the previous content.
It didn't append it.
No. You can tell it to append. I think you can tell it to append. No. There is no way with write text, but with
A stream.
with the streams, you can actually tell that open this stream from the end of the content that it has already. So let's just use these two simple read text and write text functions and not get overwhelmed with the streams for the moment. But we will actually have to, face the streams at some point, because we will connect, for example, to internet with the help of these sockets, and we will get streams from it. So for now, each time it shows the main menu and it asks to store to persistence. And then in storing to persistence, for the moment, we just want to store the products. So we have a list of product list, and let me just write a for loop for product in products product list. And as you can see, and as you it's got two properties, price and name. Each product inside this product list, as we expect, has its own price and name, and we want to store these prices and names in a way to file to restore them later. So we are iterating over all of the products inside this product list, and then we want to store them to a file. So let's just open the file, create a file, lab store file. Then, for example, I want it to be inside home, mass ID, and products. No, let's name it actually shop.txt, and I want first to struct a string that is being made off of all of my products. I want to concatenate the information about each product to a string, and then write that
All
string
of them together.
Yes, write that string to the file. So we have this, for example, let's say data. That at first it is an empty string, and after this for loop, I want to
data will have something.
Data will have something, and I will be storing it, writing that data to the store file. I will write this data to the store file. So, what is your opinion and suggestion for constructing our data from these products? And actually, we should be able to restore them later. We are now.
Because if we add them like this, they will add one after another. Yes.
Yes.
Without any space.
Yes. You can put spaces in it, but you should be able to restore it later. For the moment, we are just storing them.
Yes.
And
we should have R sign. Yes. Special character, for example.
Yes. We should have special separators. For example, for separating the information inside it.
I don't know, ampersand, or I don't know, hat sign. Yes.
Yes, we could use any character as the separators of. We need.
That's a kind of contraction. Yes.
Yes.
Between.
We are actually writing a contract for storing and restoring our data to file. We should use some separators for separating information inside the file. So, for example, we can use \n or new line character as separating our products. We can store each product in a new line, or we can use, for example, ampersand or @ sign as the separator of the properties inside the product. But we should be confident that the user actually has not used those characters and separators inside the product name, for example, because when we want to restore, if the user has been use
Insert those
those characters inside
We
one
will
of the,
separate it.
yes, it will restore it in a wrong way, you know. We won't be able to restore what we have stored. So, for example, we want something like this. We want something like this in file. Say we have apple, which is 1,000. Let's use, for example, this pipe sign character as the separator of separating the properties of a product. Apple 1,000, for example. Then I use \n because there is no way that you'll use \n or new line inside the name
Your
of the
text,
product.
yes.
And say we have orange for 2,000, and as you can see, we want our file to be stored something like this. So then later we can restore it by reading this whole text from file and separate it from this pipe and \n. So let's append to this data equals data plus this string, and instead of writing this, we can write this sign plus equals data plus equals. It is like writing data equals data plus something. So at each iteration, we want to store the product information inside string and with a separator for the next product. So let's store this product dot name, and then, for example, this pipe character, and then product dot price. But at this point, we have concatenated the content of a product, and the next product will be concatenated to this, and there won't be any sign of separation between them, and we won't be able to extract or separate or between them. So we have to, for example, add to this data, for example, equal sign or \n or whatever. For example, I use this. Let's use this plus sign as the separator of
a product.
A product, yes. And if we use this product to file, let's see what happens if we use this product to file. So we say create new file, apple 4,000, then create new file again, orange for 4,000, again another file, peach 3,000, and if we say, for example, print, you'll see that it prints all the three of them, and meanwhile it has stored
to a file.
Because at each iteration, when it shows the main menu, when we, for example, enter print something or store something, then after that it will actually store the content to the storage. It will call this function, and this function will create a shop.txt file inside in this path, absolute path, and will write this data that we have constructed from the text. So we should have shop.txt here. Yeah, there it is, shop.txt. And if we open this file, you'll see that it is apple pipe 1,000 plus orange pipe 4,000 plus peach pipe 3,000. So you see our separators. This is the separator of this product. This is the separator of this product and the next product, and the pipe separator is for separating between the properties of a single product. And if we want to restore, when the application starts, before entering this loop, we want first to restore the information from file. So I write a restore data from
file.
For example, persistence. This function does not exist. I alt-enter, ask the IntelliJ IDEA to create this function for me. Then I open this file. And then I ask this file for the content of it, read text. I say read text, and this will return to me
Whole.
the content, is the content of file. This will be the content of file that has been returned to me. And then I can use the content inside it to restore the products that have been stored before. So for that, let's print it. Let's print it. Print ln.
Print content.
For example, content of file. No, if I run the application, this will. I know that this will restore. We should complete this restore operation here, because if we don't do anything inside this restore, it will overwrite the file here, with empty. We should complete this here. So there are a lot of functions on a string that we can use, and we can ask. For example, we can ask for index of some character. We can ask for index of plus sign. This content of file is a string actually. It is a string, and we can ask a lot of questions from it. We can ask, for example, the index of the plus sign. We can ask for the length. How many characters does it have? We can write for each loop and iterate over all of its characters. For example, we can have for ch in content of file, and as you can see, this ch is a char. Yeah, it is a char. It is a character, but this isn't a string. This for loop will be continued, and all of the characters inside the string will be fed into this ch, and we can say, for example, if let's actually print ln all the characters to see what happens. Let's comment that line. Yes, I want to comment that line. I run the application, and at first it will call its restore, and as you can see, it is printing
Character by character.
each character at a new line. So this for loop actually goes over all of the characters inside that file. APPLE, apple, pipe, 1000 plus, orange, pipe, 4000. And you kind of get the idea here. And so whenever we reach to, for example, whenever the ch is a pipe character, we can take it as a sign that we have reached to the end of
a name.
Yes, a property, for example, or a price. Or else, if the ch is a
Plus.
Yes, plus sign, the character is actually written with one quote, not quotation. The plus sign.
The previous one is pipe.
Yes, this is pipe. This is pipe. And else, if it is neither a pipe nor a plus sign, so it is actually our data. It is our name or price of a product. So let's have this var product name equals to an empty string, and var product price. It is actually a string. It was an integer when we stored it in the file, but now we have asked it as a string, and we will store it as a string. Then we can convert it to integer. So we say if this character is pipe, then when we reach a pipe, we know that we have completed the product name and we are starting product price. Yes, so I use a boolean as reading name. At first we are reading a name. Yes. So when we reach this pipe, we say reading name plus false. We are reading actually. I'm writing an algorithm to restore the content, and this is my algorithm that I know. For example, for the moment, there may be a lot of ways of doing that, and I'm not going to use the functions on this string. It has a lot of functions like split. If you call a split, it will actually go and separate those strings, and it will find the separators, and it will return the whole content separated for you as an array or list of a string. Very neat. You know, it will do all of these things that we are doing here, but I want you to show the actual process. You know, I don't want you to, to think that a kind of magic is going on underneath. So this is my algorithm. I want to have a boolean, and I want to flip that boolean to indicate that I'm now reading the product
price.
name or product price. So whenever I reach this pipe, I want to start reading the product price. I know that. And whenever I reach this plus sign, I know that I will be reading name after that. Okay? Whenever I reach this plus sign, I know that I will be reading a product name after that. And now, also when we reach this plus sign, we know that the product name and product price has been read completely, and we can store it to the products list. So here we can create a product, a new product, which is empty. I call the constructor. And I know that here, this product name and price is full, has been read and loaded. So I can say product dot name equals product name, and product dot price actually asks for integer, and we have this product price here, and I call the toInt function, and it will convert it to an integer, and it will
change it to integer without any mistake.
And we have this else branch here. Inside this else branch, we are actually concatenating these characters to one of these product name or product price fields. So if characters is neither a pipe nor a plus sign, so it is a product. It is a piece of product name, or it is a piece of a product price, and we can use this reading name. If we are reading a name, so we should add this character to product name, the ch. And if the reading name is not, if we are not reading a name, so then we are reading a price. We can add to the product price this ch. So I think we are done here, and I think if I run the application and say and order it, command it to print the product list, nope. For input string, we have number format exception here. We have number format. Oh, you know what? So after storing each piece, we have to empty the product name, and the product price. Because if we don't do that, all the previous information and characters that has been stored will be we want to get them lost. We want to lose them for the new one. Okay. When we reach a plus sign, we want to empty the temporary variables that are holding to the previous product name and price. We want to empty them out for the new one that we are going to read until the next plus sign. So let's read. The application starts, and if I say print the product list number 6, there is no product. Why is that so? It is because we have not stored the product. As you can see, we have created the product, we have stored this information into the product, but we have not assigned and added the product to the product list. We have this product list, and we should add product to it. If I run the application, now this file is empty because no, it is not empty. I've commented this stored. If I press 6, you will see that it is printing our products. It has remembered what the products are. Now, if I say, for example, 1, I want to create a new product. Say, for example, banana for 6,000. And again, if I say print, we have 4 products. And now if I exit the application and run the application again and say print the product list, oh, it has
Because
not
we did-
stored because
because
yes,
we have-
we have commented this line. We have commented this line that it doesn't store. At each iteration, we want to store the new information. I say 1, banana, 5,000, 6, and this will print our 4. And if I run again, you will
Check 6.
see that we have 4. And if I check the file, shop.txt, you will see that we've got all our 4 product here. The banana, the peach, orange, and apple. So I think this is enough for this session. We have persisted our products, and we will continue from here the next session.
Goodbye, guys.
Thank
Thanks
you.
for watching
Goodbye.
and following us.